Okay. Right. So the different trig functions, y equals sin x, y equals cos x, y equals tan x, y equals cosec x, y equals sec x, and y equals cotan x. So let's start with the first one.
Yeah.
The formula that you would be needing. Do you know the formula for sine c plus sine d?
Sine play. I mean, I'm not sure what you're asking.
There are these formulas that we'll be using while
Oh,
differentiating.
okay. No, the adding formula like that.
Yeah.
I
Sine a
mean,
plus b plus sine a minus b.
we didn't. So when I'm doing that pre-calc units, they just give you the formula sheet and we have to apply it. I don't have it like by knowing them. I don't have it yet.
That's fine. Even if you don't have to by heart it, but
Yeah.
I'm just wondering if I can directly use it, or do you need any review of these topics from pre-cal, or I can just start using it? I mean, I don't want you to start feeling.
I think if I feel like confused, I'll let you know.
Okay.
Because yeah, I just implemented those formulas,
Okay.
not
Okay.
like derived them.
But you should go through the proof if you haven't already.
Okay. Right. Yeah.
Go through
I'll
the
go
proof.
through.
Yeah. Okay.
Yeah.
So y equals sin x, right? The way we write it is f of x. That's your function. Our aim is to find the derivative of sin x. So limit h approaches 0, sine of x plus h minus sin x upon h.
Yeah.
That gives me limit h approaches 0, sine of x plus h minus sin x over h. How do I solve it? Sine. That's sine c plus sine d that I'm going to use. Sine c plus sine d. It gives me 2 on sine c plus d upon 2 cos c minus d over 2. Let's hope I'm not wrong with the formula. I think I'm correct. I also don't memorize the formulas, but I know how to derive them. So if I derive them, then there's no mistake. Okay. C plus d upon 2. Let's see. Check if I'm wrong, I will know. Minus x over 2 into cos x plus h. Oh, what did I do? This is plus, and this will be minus over 2 h. So what will I get? Limit h approaches 0, sine 2x plus h over 2 over h cos h over 2. Look, there's something wrong here. I made a mistake. I'm going to quickly derive this, see if you understand. I think I know what my mistake is, but I'm nonetheless still going to derive it. Sin a plus b plus cos. Oh, this is negative. I used the wrong formula. So this is supposed to be negative. Sin a plus b, sin a minus b. So when I open this, I'm going to have sin a cos b make it this cos A sin B minus sin A. Cos the signs are a bit different. Plus minus sin A cos B plus cos A sin B. Yeah. So this gets cancelled. You have 2 cos A sin B.
Yeah, that looks more familiar.
Yeah. That's 2 cos C plus D by 2 into sin C minus D by 2. That's the formula I'm supposed to use. So I'm just going to correct this. I was supposed to use 2 cos this and sine of this. So just erase this whole thing. Limit h approaches 0 to cos 2x plus h over 2 into sine h over 2 over h. So that gives me limit h approaches 0 cos 2x plus h over 2 multiplied by limit h approaches 0 sine h over 2 over h over 2. Now this is becoming 1.
Wow.
So you have cos 2x over 2, which gives me cos x. And that's your answer. So what have we done? We found the derivative of sine x, which comes to cos x. Go through the proof. Tell me if you've understood everything, or are there any parts that you need explanation for?
I think little enough. Yeah.
Obviously.
Yeah. Yeah, quick question. So in the sine h by 2
Mhm,
divided by h,
mhm.
in the sine h by 2 divided by h.
Sine h by 2 divided by h. Yeah, what happened? What part?
Yeah, so from that, how do you get from denominator being h by 2?
So you have sine h by 2 over h, right? But there is a 2 here. You see that? I took that down in the
Oh,
denominator.
okay, then just, yeah. Okay.
Is that clear?
Yeah. We just multiply with 2 by 1.
Yeah, just
Then we got,
multiply and
right.
divide.
Yeah. Yeah. Okay, yeah, right. I got it. Yeah. I
Cool.
think I just have to know how to derive from sine a plus b. Then,
This part?
Yeah, I just have to like know how to do it by myself in the proof.
Okay, so you mean this part, right?
Think a little glitchy, so can you repeat that again? Yeah, right, yes. Yeah.
Okay, I think I mean that's all pre-cal, so you just go through it and you'll know.
Yeah,
If
I'll
you've
do
done
that
Trigo properly, you'll know.
anyways, yeah.
Yeah,
Right, yeah. Right,
yeah.
yeah. I mean,
Look,
I
go through
understood, sir.
proofs.
All
Proofs
that's
are more important.
yeah,
Okay, you don't have to make formulas. Yeah.
right, yeah.
Okay. All right. Let's do y equals cos x then. Let's write it as
Yeah.
f of x equals cos x. So f of x plus h will be sine x plus h. Now you have derivative of cos x equals limit h approaches 0 cos x plus h minus cos x over h. Now, for me to solve this, I would need to use the formula cos c minus cos d. Now, instead of c, I'm going to take c as a plus b. C is a plus b, and d is a minus b. That's what c and d stand for. So, if I open this up, I get cos a cos b minus sine a sine b. That's cos a plus b minus cos a cos b the plus minus sine a sine b. So what you have here is negative 2 sine a sine b, which is the same as negative 2 sine c plus d by 2 sine c minus d by 2. This is the derivation. This is going to be used. This is what we're using
Okay.
now. Okay.
Right, yes.
All right. So equals limit h approaches 0 negative 2 sine x plus h plus x over 2 multiplied by sine x plus h minus x over 2. That gives me limit h approaches 0 negative 2 sine 2x plus h over 2 multiplied by limit h approaches 0 sine h over 2. All clear till here?
Yes.
I've missed something. Tell me what I missed.
Negative sign. You could have oh no, you can't. Yeah.
It's very elementary. Whatever I missed is very basic.
Okay.
And I've missed something in the second last step. I missed something here.
Minus 2. Oh, you would cos.
I put cos.
Yeah. So you put minus 2 cos 2x h 2x plus h divided by 2.
No, this is still sine. Look, the formula I used, the one I derived, this both of these are sine. Where is cos? Both are sine.
No, in the original thing, you're minus 2 cos.
What is that?
In the original thing, you wrote minus 2 cos.
No, both were sine. That's why I erased
Okay,
both of them and wrote sine again
okay,
clearly so that you see. Both were sine, 100%.
okay.
What did I miss?
Multiples.
And anyways, that's not what I'm talking about. I missed something else.
Okay.
I missed something else in
2x.
this step. In this step. This step that I've written, this step, something here.
Okay.
So look again. Come on, you can search this. Finding mistakes is a very important part of math. Come on, come on. Tell me when you give up. Okay, that's a lot of time.
Yeah, I'm not really sure. Yeah. Is it
Look,
something to do with
this
formulas, sir? The
no,
C
it's
plus
not.
D
Look,
divided by 2.
I implemented the
Okay.
formula correctly. That's what I told you. It's very. What happened to that? Where did that?
You're glitching, sir.
I forgot about that H completely. Right? So I'm just going to write a H here.
One,
I'm going to rewrite this
I
step.
think you're glitching. I think you're glitching, sir. Could you repeat?
The H, this H. Can you hear me?
Oh, no, yeah, right. Yeah, I can see it.
Yeah. So I'm going to just rewrite this step. Okay.
Right, yes.
Limit H approaches 0, -2 sine x plus H plus x over 2 sine x plus h minus x over 2, the whole over
all
h.
divided by h.
So this gives me what? Limit h approaches 0. I'm going to distribute the limit now. Minus 2 sine, and my h is here. I'm going to take the 2 out. So negative sine 2x plus h over 2 multiplied by limit h approaches 0 sine h over 2 over h over 2. Good.
It'll become 1, so it'll be negative sine x.
Yes, that's
1
correct.
d.
So this whole thing becomes 1. And here, when I apply the limit, my h becomes 0. I have negative sine, what is this? Sine x, so that's 2x over 2 multiplied by 1. That gives me negative sine x. Good.
Yeah, yes.
So we have two things done now. One is derivative of sine x, and one is derivative of cos x. Derivative of sine is cos, and derivative of cos is negative sine.
Negative sine.
Yeah.
Got you. Oh, okay. Yeah, yeah. Okay. Then, yeah. After like seeing the thing, I was then thinking, why wouldn't the h go for both of them? But since multiplication doesn't have.
Yes. Okay. Please ask me
Yeah.
doubts like these. Don't have any
Yeah, yeah.
hesitation.
Right. Yeah.
Okay. All right. Let's go for the next one then. Y equals tan x.
Yeah. Yes.
You want to go through this? Is this clear?
Yeah, I
Obviously, you
written
can take
down such.
screenshots. If you want to write
Yeah.
it down, you can write it down. And this is
Right.
also in your book, so you can refer to
Okay.
that.
Yeah. Right.
F of x equals. Can you hear me?
Sorry, sir.
F of x equals tan x. So f of x plus h equals tan x plus h. Derivative of tan x equals limit h approaches 0 tan x plus h minus tan x over h, right?
Yeah.
Now, how do we solve this? Any clue? What formula can I use?
I mean, immediately two things came in mind. Tan is signed by cos, and also like a separate formula is for tan a plus b.
Um, so what I'm going to do is convert the tan
Into sine
into sine
divided by
cos.
cos. Oh,
So this becomes sine x plus h over cos x plus
x.
h, right? Oh, why am I even writing this? You
Yes.
know this. This is very elementary, right?
Yeah. Yeah.
Okay. So that makes it sine x plus h over cos x plus h minus sine x over cos x over h.
Yeah.
Limit h approaches 0, sine x plus h into cos x minus sine x cos x plus h. The whole thing
We
over h, correct?
Oh yeah, right. Because we just tried to be in the same. I thought first you're trying to implement for those two formulas.
You got this?
Yeah.
Okay.
We
I missed
just made
something. I missed
denominators.
something.
Or so
Yeah,
then
but now in this step, I missed something. Can you find out what I missed?
I mean, as we like multiply each side, we have to the denominator will be cos x times cos x plus h.
Correct. That's what I missed. So
Oh,
h cos x plus h into cos x. Right
yeah.
now, what do we do? Okay, let's split the numerator and distribute the limit. So limit
Yeah.
or you know what? Sin A cos B minus cos A sin B. Right? The formula sin A
You're right.
cos B minus cos A sin B is the same as sin A minus B.
Humans. Oh,
Sorry. So I'm going to use that formula here, sin A minus B. That gives me limit h approach minus x over h cos x plus h cos x.
good.
Clear?
Then we sin h. Yeah, sin divided
Doubts?
by that. Or no,
Negative the positive. Okay.
just one doubt on the
Now I'm going to
previous steps.
distribute limits. Limit h. Yeah,
One doubt on the previous steps. So with the sign, yeah, sin x plus h times cos x minus all that one.
yeah.
Wouldn't we kind of like have it separately into sin x plus h times cos x divided by cos x minus sin x times cos x plus h divided by h cos x plus h. So,
I am not sure if I completely got your question, but look, A
yeah,
over B minus C over D over H, right? That's what we have.
yeah,
Sin x
right,
plus
yeah,
h over cos x. So I'm just representing it
yeah,
by single variables.
yeah,
So,
yeah.
so when I solve this, I'm going to get AD minus BC
Divided by
over
bd.
BD, the whole over H,
So it'll be
which,
hbd,
which can then be written as AD minus BC over H into BD.
hbd. Yeah.
That's what
Oh
we've
yeah.
done.
Then we can't. Yeah. Then we can't do it like that. Yeah. Got it.
Your doubt is clear, right?
Yeah. Right. Yeah.
Okay. Okay. Can I move on then?
Yeah. Yeah. Right. Yeah.
Okay. Okay. So what I have left is sin h over h into limit h approaches 0, 1 over cos x plus h into cos x. This obviously becomes 1,
We won.
and this becomes 1 over
One.
cos x into cos x, which is the same as 1 over cos square
Cos
x,
x.
and you can write that as sec square x.
Got it.
So that's your derivative of tan x.
Okay. Yeah. But there's also a quick question here. So it said
Yeah.
limit h extends to 0, 1
Mhm.
divided by cos x plus h times cos x. So
Sorry.
wouldn't, yeah, no worries, sir. So wouldn't be 1 divided by cos squared x? And if you are extending to 0, so it'll be 90. So it'll be 1 ultimately, right? So,
What? No, wait, what? If you substitute the value of h as 0, you will have 1 over
yeah.
cos x into cos
So
x. Yes.
Right. Oh yeah. One by cos x is one. I mean, 1 over cos x is one.
Yeah, 1 over cos x is 1.
Well, yeah.
No, 1 over cos x is not 1. 1 over cos x is sec x.
H.
It's a
I mean,
reciprocal
if
of cos.
h. Sorry, if one over cos h, if h extends to 0, then it will be 1, right?
Oh, one more time. 1 over. What are you
Yeah,
saying?
1 over cos. One. I think. Yeah, I think I just solved my own dot. I thought the x was with the h. So from that, if it's cos h, h extends to 0, it will be 1. But it's
Yeah,
x now. It's not. Yeah, so it won't. Yeah.
yeah. Only h is approaching 0. So only
Right.
the
Yeah.
h becomes 0.
Yeah.
So x plus 0 is x.
Yeah. Right.
All right. So
Yeah,
you
I
got
got
all
it.
three of them now. You have derivative of sine x, which is cos x, derivative of
Yeah.
cos x, which is negative sine x, derivative of tan x,
Yes.
which is sec square x or 1 over cos square x.
Yeah. Yes.
Yeah. So jumping to this, they are done with x of sine x, which is cos x, divided by dx of cos x is minus sine x, and oh, so they haven't gone ahead. Okay. Then there is tan x here.
Yeah.
And there are some still. So they okay. So they are not going into the other three functions. So there is no so when we started, I told you that there are these 6 functions, right?
Right.
Sine,
Yeah.
cos, tan, cosec. So we are done till here.
Till tan.
These 3 did not show up in your book. If you want, we can do it. If we want, we can go ahead with the flow of the book.
Okay, I think we'll go with the flow of the books
Sure.
because yeah, they might show up later on.
Yeah, maybe. All right. So um that's the topic of
I think you're lagging here.
part of section. I think I have enough time to finish the topic. Can you hear me now?
Now I can hear.
Can you? Okay. Just want to move. Maybe I'm hoping this head towards the direction of Wi-Fi. If that's a problem, I don't know what the problem is. Okay. Um, let's pick up a few sums and solve them.
Yeah, it is.
Okay. Question 5.
Um, yeah, it's on
Question
the
5.
page. Yeah, it's
Sorry.
not on the page. You're on the page.
It's what is it showing? What page number is it showing?
212, sir.
212. Okay.
Okay, yeah, now it's
Okay. Still glitching, I guess. Question 5.
yeah, okay. So it'll be this derivative from this.
I think you can do this
One
mentally.
minus cosec, sir.
Correct. Perfect. Um, how about 13?
13.
Yes.
3 times t minus t sine t, sir.
Minus t sine t. Are you missing something?
Oh, okay. No, we'd have to multiply
Yes,
because
it's a use the product rule.
right. Yeah. Product rule would be a prime times b minus or a plus b prime times c.
Yeah, that's correct.
Oh yes, I got cos t plus minus sin t times t
One more time. Minus sine t.
times t.
Sorry, I couldn't hear you. One more time.
Yeah, so overall cos t plus cos t minus sin t times t.
Yeah, perfect.
Okay. Oh
Um,
no, minus t sin t. That's for sure.
yeah, minus t sine t plus cos t, right? The other way around. Yeah, okay.
Yeah, yeah.
11th sum.
11. Okay. Sin x cos x. Yeah, I got cos squared. Yeah, cos x squared minus sin x squared. Huh?
Cos square x minus sine square x.
Right, yes.
Okay. How about you got this one? Let's choose something more challenging. How about 17?
17, okay. So, oh, what would be the derivative secant from here? Is it just
That
1
you don't need
by...
to. So it was not a part of the flow of the book. So they're not expecting you to use the derivative of
Okay,
secant. You'll have
okay,
to use trigonometry to solve this now.
okay. Oh, yeah, I think I'm not sure it's a like full answer, sir, but we got pi secant x times tan x plus um, pi secant to the cube x, sir.
Let's solve this.
Okay,
So that's y equals sec u into tan u, and there's a pi, right?
yeah, pi, yeah,
So dy by dx is what I want to find. It's derivative of pi. Instead of sec u, I'm going to write that as 1 over cos u. And
okay,
tan u is just sine u over cos u.
okay,
Now,
yeah,
this helps me get it really simplified. Pi
right,
d
yeah,
by dx of sine u over cos square u. So that gives me pi. Now, I'm going to use the quotient rule. So
yeah,
cos square u d by dx of sine u is again cos u. And there's a minus sign here, right? Or is there a plus sign?
quotient rule times,
Plus. Just check if it's minus. If I'm wrong, let me know.
yeah, yeah,
Sine u d by dx of cos square u. Now, isn't that a problem? We haven't done chain rule yet.
nah,
So how do I teach you without the chain rule? There are a lot of hoops I need to jump through. Derivative of cos square u I know, but I can't use it because you are not done with chain rule.
also, so I think it's negative, negative, because it goes like g of x times f prime minus g prime times f, or divided
So
by
you
g.
think this is negative.
Yeah, I think.
Okay. Nah, maybe I don't remember. We can derive it if you want. Not. Um, what do I do about the cos square? How else can we do this without using the chain rule? How about? How about? So what we'll do is we'll try to attempt this separately. We'll use a rule inside a rule. So pi d by dx of 1 over cos u into sine u over cos u. So right here, there's a multiplication sign. That's a product rule. So we'll use the
Yeah,
product rule first. 1 over cos u d by dx of sine u over cos u. Yeah, why don't I do that? Why don't I do that? It's much easier, right? Sine over cos is tan. So what I'm going to do is 1 over cos u into d by dx of tan u plus tan u d by dx of 1 over cos u.
yeah. I'm just curious how you got the d of dx like kind of moving, so, I mean, like
Moving what?
Like even from
What's
d
moving?
of dx of pi divided by cos u times sine u divided by cos u.
Product rule, no? This into this product rule. That's what you're asking?
No, but like from the d of dx is d of dx pi divided by cos u. Like how
So
did the oh
are you asking me how the pi came out?
yeah, right.
It's a constant.
Right, yeah.
You remember this? Look,
Yeah,
feel free to
yeah.
tell me if you need a review of anything. We
Right,
can go
yeah.
back and
I was just thinking of like a variable from that, but yeah.
yeah, no, it's
But-
okay. So now, so that makes it pi 1 over cos u d by dx of tan. Oh, I'm making a mistake here, which I realize now. This is supposed to be u, not x. I'm so used to writing x.
Okay.
So all of this is u, okay?
Yeah, yes.
Not d by dx, it's d by du. And if I do d by dx of tan u, that means something else.
Okay.
Okay. So now d by dx of tan u is what we've already seen. That's sec square u plus tan u. Now is the challenging part, interesting part. How do we differentiate 1 over cos u? So that's going to be the quotient rule. Cos u
Okay.
d by dx of 1 minus 1 d by dx of cos u, which is minus sin u, over cos square u. So pi sec cube u plus tan u into sin u over cos square u. All clear till here?
Yeah, yes.
Okay. So pi sec cube u plus
Yeah.
tan square u into sec u.
Yeah.
And then the final step,
Uh,
pi into sec u we have sec square u plus tan square u. We can simplify this further using Trigo. Sec square is x is 1 plus tan square x. So 1 plus 2 tan square u. Or you
yeah,
can
I
say
think
tan square
that's
is x is sec square x minus 1. So 2 sec square x minus 1.
yeah, till then
Both of
that's
that.
what I got here originally. So I got pi secant u into tan theta u tan squared u plus secant squared u.
This one? This is where you reached?
Yeah, yeah. Right, yeah.
How did you reach
Because
here?
I just multiplied.
That's a coincidence. You can't do that.
Oh, okay.
What did you multiply? Maybe I'm not understanding. What
With
did you multiply?
the pi secant u and tan u. So
Pi secant u tan u. Multiplied as
yeah,
derivative of sec
just
u into derivative of tan u.
like
Is that what you
just
did?
product rule, so
Yeah, but then you don't know the derivative of sec u, no? We found that out here.
I just
Look here, that's derivative of sec u. We solved it to get this, to get this. That's the derivative of sec u.
okay. I theta. Yeah, I don't know. I think I just assumed it was one. I don't know.
Did you do d by du of 1 over cos u as 1 over sin u minus sin u?
What is it?
What? How did you solve this? D by du of 1 over cos u or sec u. How do you solve this part?
Like I converted with the cos squared.
Where is the cos squared squared? You used the
Oh wait, no.
quotient rule, or what did you do exactly to solve this further? D by du of sec u. How did you solve that?
So with the sec u, uh,
You
oh,
asked
I
me,
think I
right?
just
You
saw the
asked me.
formula here. So yeah, I just saw the formula, I guess, with
Okay.
this
Okay.
because it's up in the show set formula.
Where?
Page yeah, 209.
209.
Yeah.
Ah, you
First,
use
I had to
this.
list them down.
So
Yeah.
so they haven't differentiated and found out the proof of this. Let's
Right.
do
Yeah. I mean,
this
I don't know
anyways.
how to prove. Yeah. Yeah.
D by dx of sec x. So then we can directly use these formulas. So d by dx of
Oh
sec
yeah.
x is, how do I find this? So it's limit h approaches 0. Oh, you know what we can do is, instead of using the first principle, we can do d by dx of 1 over cos x.
Yeah.
Now, you don't have the derivative of sec, I mean, to find the derivative of sec x, we can use the quotient rule. So cos x
Okay.
d by dx of 1 minus 1 d by dx of cos x over cos square x. So that gives me cos x into 0 minus d by dx of cos x is negative sin x over cos square x. So that gives me sin x over cos square x, which is the same as tan x into sec x. Clear?
Yes.
That's d by dx of sec x.
Yeah.
Next, d by dx of cosec x. You think you can do this? You tell me and I'll write that down. You help me prove
Cosec.
this.
Okay. So that'll just be 1 by sine x. Then from that, we
Sorry?
go already to the 1 by sine x.
Okay, so what do I write down? You just dictate it, I'll write it down.
Okay. You know, I'm just writing the previous formula down.
You want to see the previous one?
Yeah, I'm still writing
Okay.
those. What's here?
Yeah. Okay.
So one by sine x. Yeah, divided 1 by sine x.
Okay.
Then from here, the quotient formula would be sin x f1 prime, so it'll just be 0. So
Mhm.
I'll just write down here. I think I just want to take step by step, not reach
Sure,
to
yeah.
conclusion.
You
So
want
it'll
me to
be d
write
of
d by
dx
dx of 1?
1, yeah.
Okay.
So because I don't like overthink and mess something up for me.
Okay. Okay.
It'll be minus 1 times prime of that. So it'll just be cos x. But yeah, I'll just write it down. Divided by the sin x squared.
All right.
Yeah, then from here it'll be 0 minus cos x.
One more negative. One more negative? Are you saying minus
No,
cos
no,
x?
no.
Just cos x.
Sin x is, yeah, it'll just be, yeah.
Okay.
Because the derivative of sin x is cos x,
Yeah, I'm
just
fine.
cos x. That's,
I'm just trying to understand what you're saying. Okay.
okay. Then divided from here will be sin x squared, so it'll be minus cos x divided by sin x times 1 by sin x.
Perfect. That gives you minus
Okay.
cot x into cosec x. You can
Yeah,
directly start using these. Now the last one is
codine.
your d by dx of cosec x. I didn't see the proof, so I thought that they aren't covering it, but they are covering it. They're just
Oh,
writing the
no,
formula.
yeah, it showed right. That's why I just
Yeah,
copied that down.
yeah.
But yes, better know the proof of it than
Always good to know
this.
the proof. When you
Yeah,
do the proof, that's when you're doing mathematics.
yeah.
Substituting is and applying is different than understanding where it comes from. Okay,
Mhm.
so cos x d by dx of sin x minus cos x d by dx of, oh, am I repeating? Sorry, sin
Yeah, it will
x
be sine.
d by dx of cos x over cos square x.
Wait, wouldn't it have to do cos x divided by sin x, huh? Because if you're doing cotangent.
Oh, I wrote tan. Sorry,
Right, yeah.
my problem, my fault. Let me.
Yeah, no, no.
I wrote tan and I started doing tan. I don't know for what reason.
Yeah.
Okay, so thanks for helping me there. D by dx of cot x, which is d by dx of cos x over sin x. So that gives me sin x d by dx of cos x minus cos x d by dx of sin x over sin squared x. So that gives me sin x d by dx of cos x is negative sin x minus cos x d by dx of sin x is positive cos x over sin squared x. So that's the same as negative sin squared x minus cos squared x over sin squared x.
Will be,
That will give me negative 1 over sin squared x, which is negative cosec squared x. Good.
yeah, yes.
So derivative of cot x equals negative cosec square x. Easy.
Yeah, yes.
Okay. All right. So how about we solve one more? Oh, are we over time already?
Oh, yeah, yes.
Okay. You think we should stop here then?
Right. Yeah, I'll do the 2.5, sir. Then I'll ask.
Sure. So
Right.
yeah, I think you should solve 2.5 and come to me with doubts if any.
Yeah, one more thing, sir. So
Yeah.
with all of them except sine and cosine, we used the quotient rule to kind of figure out the function, the derivative function.
Sorry. What part?
So
You're
like
talking about
with,
these three parts.
yeah, so with secant, cosecant, and cotangent, with all of them we use the quotient rule to find like
Yeah.
its derivative.
Yeah. Yeah. I look. Ideally, you can use the first principle as well. Right?
Okay.
Can use the first principle as well, and you'd get the same
Yeah.
answer. So that's fine.
Okay.
Whatever
Yeah.
you use doesn't matter. Even I could
Yeah.
have started proving things from tan itself. I could have used quotient rule here as well, but I
Yeah,
didn't.
right.
So whichever
Okay.
method you use, depending on how efficient you're with mathematics, how well do you know your concepts, things will help you. If you prove this using limits as well, that
Okay.
shows how good you are at limits as well. No?
Right.
So it's useful to do it
Okay.
both ways. It's good.
Yeah.
Yeah.
Right. Yeah. Those 2.5.
Yeah, you'll finish 2.5 and let me know. I think that's the end of chapter 2. We'll be starting with chapter 3.
Right. Yes. Okay,
So,
sir. Yeah.
yeah. All right. See you tomorrow.
Have a good day.
Yeah, you too. Bye.